Okay, second part of 6.3 and the graphs along with their transformations and things like that. You already have this table in your notes that's at the top of the second page. A lot of this stuff you already know. The biggest one that is kind of key here is going to be with the horizontal stretch and shrink. Okay, so if you have, and I guess realistically the one that you don't see a whole lot of is reflecting over the y-axis. Okay, there was one in your homework, I don't remember if it's 5 or if it's 4 or 5, that it has like a negative x on the inside with your logarithm. A negative is just going to flip or change sides. It's just a matter of which side it's getting reflected over. Remember, anything on the inside, just like we've had here with horizontal, it's always the opposite of whatever normally would happen. So if it's a log of x minus 4, normally when you think of a negative 4, we would move to the left, but since it's horizontal and since it's inside, okay, anything inside with that x that's going to change it horizontally is going to be the opposite, so it always moves to the right. Okay, remember whenever we look at our x value or our h value, then it's always opposite. Whereas whenever we talk about like a vertical translation and the k, if it's a plus 3, it goes up 3. If it's a negative 1, it goes down 1. Okay, it is what it is. But whenever you have anything that deals with your horizontal stretch or shrink or reflection, it's always going to be the opposite. So the biggest thing here is where it's circled of horizontal stretch and shrink is if you have a number, so normally whenever you have a vertical stretch or shrink, if you have a number bigger than 1, it's going to be a stretch. If it's a number between 0 and 1, it's going to be a shrink. Whereas here, whenever we deal with a horizontal, if it's a number bigger than 1, it's going to be a shrink by the reciprocal. Okay? It's basically, instead of like a vertical shrink or a stretch, it's like I'm grabbing the bottom and the top and I'm either pushing it or I'm either pulling it apart or I'm squeezing it together like it's a sandwich and I'm squeezing the two ends of the bun together, okay, or the bread, and kind of flattening everything out. Whereas whenever I deal with a horizontal stretch and a shrink, I'm grabbing it by the sides and I'm either pushing everything in, okay, and squeezing everything together, or I'm pulling everything apart. Okay, by the sides instead of the ends. Kind of instead of like the head and the feet, I'm grabbing by the arms and I'm either squeezing it together or I'm pulling it apart. So whenever you deal with a horizontal stretch or shrink, it's always going to be the opposite. So if it's a number bigger than 1, it's going to be a shrink, and then you just do the reciprocal. Okay, so 4 is just 1/4. If you have a 1/3 in there, it's a number between 0 and 1, so it's going to be a stretch by 3. Again, all we did to get the stretch and the shrink as far as the 1/4 and the 3 is we just flipped that number upside down. Okay, we just did the reciprocal of 4, which was 1/4. We did the reciprocal of 1/3, which was 3. If it would be like 2/3, then it would be we would just do the reciprocal of that, and it would be 3/2. Okay, so it's opposite of what it normally is whenever we deal with like a vertical stretch and a vertical shrink. Okay, everything's the opposite. So instead of it being, if it's bigger than 1, then it's going to be a shrink. If it's smaller than 1 or between 0 and 1, it's going to be a stretch. So whenever we write this, if you go to the back page, where it gives us different, it says let the graph of G be a reflection, it should be on the x-axis, followed by a translation of 4 units to the right of the graph of 2 to the x power. write the rule for g. So whenever you have any sort of thing that's going on, you want to take it one step at a time. Don't try to do everything all at once. So you want to write down, like, where are we starting? What's the starting function? It's like we're going to take this function and we're going to have f of x, and it's going to be equal to what? 2 to the x power. So what you want to do here is basically it's going to transform or change everything right in front of your eyes. Okay? And we're going to do everything in steps. So we have f of x is equal to 2 to the x power. What's going to happen is after we change this, we're going to have basically down at the other end, and we're going to have it's equal to our new function, which is g of x. Okay, and what we're trying to do is we're trying to fill everything in kind of in the middle. So whenever you do this, just take it one step at a time. So if we start with 2 to the x power, the first thing it does, or the first thing it tells us to do, is to reflect it over the x-axis. So if we reflect it over the x-axis, it's a reflection, so there's a negative. Is the negative on the outside, or is it up with the x power? Where does anything that's reflected over the x value, or the x-axis, excuse me, where does that negative go? On the outside. So then what's going to happen is I'm going to change this 2 to the x power, and it's going to be written as negative 2 to the x power. All I did was just reflect it over the x-axis. The next thing that it tells me to do then is it's followed by a translation of 4 units to the right. So is it moving horizontally or vertically? It's going to the right. Horizontally. So if it's going horizontally, then I'm going to deal with the x value. It's going to be up here. So how am I going to write something that is a horizontal transformation or translation of 4 units to the right? If it's going to the right, say it louder. X minus 4. So I'm going to have negative 2 to the x minus 4 power. Is there anything else that I'm doing? No. So then my new function that I have is just this right here. Okay? Whenever you're rewriting a new function after everything that's given to you, all you're going to do is you're going to start with where you begin. They're going to give you the f of x function, and then we're going to get it to where we're going to basically write it as g of x. You may only have to translate or transform one thing. You may have to do 2 things. You may have to do 3. The biggest thing is take it in steps. Don't try to do everything all at once. So then if we have f of x for the second one, if we have f of x equal to log base 1/3 of x. Again, I'm turning this thing into g of x at the end. Try not to read everything all at once. Try to go in steps. So if I'm going to go in steps, first thing I'm going to do is translate it 2 units up. So how am I going to translate something if it's log base 1/3 of x? How am I going to translate it 2 units up? Plus 2, where at? Inside the parenthesis or outside it? Outside it. Oop. So log base 1/3, that doesn't change. The x doesn't even change in the parenthesis, and I'm just going to go plus 2. The next thing then says, followed by a vertical stretch by a factor of 2. So I moved it up 2. The next thing I have to do is stretch everything by 2. The biggest question here is what's going to get multiplied? Huh? Log? So if we go 2 log base 1/3 of x is it going to be a plus 2 or a plus 4? Okay, if it's inside your parenthesis or if it's taken to a power, there are some cases to where everything's going to get multiplied. This is not one of those cases. Okay, we moved it up 2, and then we stretched everything out. Okay, but know that there are some cases. Okay, depending on what, a lot of it's really just depending on the order, as far as if that 2 is going to get multiplied by 2. Okay. All right, last one then. Let's do B because it does everything. Okay. So whenever we graph a log, we are going to do the 4 things. Okay. Obviously, it's a graph, so there's here. Remember, we have the asymptote, we have the x-intercept, we have the domain, and the range. First thing we do every single time for a logarithm is which one? The range. Range is always negative infinity to positive infinity. Second step, asymptote. Remember, asymptote is the opposite number here. So if it's a -5, it's actually at x equal to 5. So then I'm going to put a dashed line at 5. Now, the hard part here is going to be to do the x-intercept. So remember, whenever I do the x-intercept, what am I plugging? Where am I plugging the 0 at? For what value? For the it's x-intercept, so I want it to be x equals, so I'm going to plug the 0 in for y. So I'm going to have 0 equals 3 times log base 2 of x minus 5 plus 3. Now, I need to get the log base 2 of x minus 5 by itself. So what do I need to move first? The 3. So the plus 3. So I'm going to subtract 3 first. So I'm going to have -3 equals 3 times log base 2 of x minus 5. Now what do I need to do? Divide by 3. So I have -1 equals log base 2 of x minus 5. Now I have a log, so I need to turn it into what? Exponential. So if I turn it into an exponential, I have 2. Where does the negative 1 go? To the exponent, and then I have x minus 5. What is 2 to the negative 1 power? 1/2, right? So I'm going to take it up here. So I have x minus 5 equals 1/2. How do I get x by itself? Add 5. So I'm going to have basically, I'm okay with you putting, like in this case, 5.5 or 5 1/2 or 11 over 2. It's really up to you. Okay? It really doesn't matter to me as far as how you write it. If you write it as x equals 5.5, or if you write it as 11 over 2, or if you write it as 5 1/2, it really doesn't matter to me. So then, about where's 5 1/2? Just to the right, isn't it? Right in the middle. So is it on the right side or the left side? It's on the right side. So then where's my domain coming from and going to? 5 to positive infinity. Is it exponential growth, or excuse me, is it a logarithmic growth or decay? Is it going from the bottom up or from the top down? Bottom up, right? Okay, why is it bottom up? Because of that 2. So it's going to look something like that there.